In this video, we're going to look at how to factorize, and in particular, how to factorize using the highest common factor method. Now, factorizing, for those who haven't used it before, is the opposite to expanding. So when we were expanding, we were given equations in brackets and then expanded them outside of those brackets into a different form. Now we're taking that expanded form and putting it back into brackets. And those applications come in really handy when we start doing graphing parabolas later in the topic. So highest common factor should be a term you've heard before. And factors, as we know, are two numbers that multiply to get another number. So in this case, for 6, we have 1 times 6, which is 6, and 2 times 3, which is 6. Our factors of 12 are 1, 12, 2, 6, 4, and 3. Now, we wanted to know what the highest common factor was between 6 and 12. We know that our common factors are 1, 6, 2, and 3, making our highest common factor 6. So this is stuff you've seen before. What we're doing in this topic is we are going to put an algebra context to it. So let's look at an example. If I have the equation x squared, I know that if I break x squared down, that this is essentially 1 times x, because we know that the coefficient of x squared, when there's no coefficient written, that's just 1, and then x times x is x squared. If I have an equation such as 2x, we know that this is the same as 2 times x. So the two of the factors of 2x are 2 and x. The way I go about using the highest common factor method is I split the equation into two parts, the coefficient and the variable. So for x squared, my coefficient is equal to 1, and my factors of 1 are just 1. We know that factors of 1 is just itself. Then my variable is x squared. Now, our factors of x squared are 1 and x squared, and x and x, or just x we write down. We don't need to write down both. So they are our factors of x squared. Now, if I look at our second term, which is 2x, our coefficient is equal to 2. Our factors of 2 are 1 and itself. Our factors of our variable x are also just 1 and itself. So if I was trying to find the highest common factor, or factorize using the highest common factor method, x squared plus 2x, I can see that for our coefficients, our highest common factor is 1, and our highest common factor for a variable is x. So what that means is we take our highest common factors outside of the bracket, so we would put 1x, or in this case just x, means the same thing, and then everything else goes inside brackets. So x squared divided by x is just x. 2x divided by x is just 2. So the factorized form of x squared plus 2x is x times x plus 2. Now we can prove that using expansion, because like I said at the start of the video, expanding and factorizing are opposites to each other. So if I expand this, x times x is x squared, and x times 2 is 2x, which is our original question. So that works. Let's look at a different example and applying the highest common factor method. So let's look at the equation 2x squared plus 4x. To start with, I'm going to look for my common factor, highest common factor of our coefficient. So our coefficient of 2x squared is 2, and 2 has factors of 1 and itself. Our coefficient of 4x is just 4, and our factors of 4 are 1 and 4 and 2. So we can see that our highest common factor between our coefficients is 2. Next, let's look at our variable. So our variable for 2x squared is just x squared, and our factors of x squared are 1, x squared, and x. For 4x, our variable is x, and our factors of x are 1 and x. So we're looking for the highest common factor between x squared and x, that is just x. So that means when we're writing our answer to our factorized form of 2x squared plus 4x, the values we're taking out of our brackets are 2 and x. And we divide every term, we divide 2x squared and 4x both by 2x, and that's what goes inside our brackets. So 2x squared divided by 2x is just x, and 4x divided by 2x is just 2. So our factorized form is 2x times x plus 2. And once again, if we wanted to prove that that's correct, 2x times x is 2x squared, and 2x times 2 is 4x, which is once again our original equation. Okay, let's look at a slightly more difficult example. So we have the equation 4x squared y minus 6x. Now, this equation here has got 3 different variables or 3 different items that we need to look at for common factors. So let's start with our coefficients. So our coefficient of 4x squared y is 4, and that has factors of 1 and 4 and 2. Now our coefficient for 6x is just 6, and those factors are 1, 6, 2, and 3. We can see that our highest common factor between them is 2. Next, let's look at our x variable. So our variable for x is, for our first term, is x squared. So our common factor here, our factors of x squared are 1 and x squared and x. Our variable in our second term is just x with factors of 1 and x, making our highest common factor between them x. Now, for y, our second term doesn't actually contain a y, so there's no common factor for y in either term. So that y is going to stay in our brackets. So that gives us a final answer of taking 2x outside of our brackets, and then left inside we have 4x squared y divided by 2x, which is 2xy, and then 6x divided by 2x, which is minus 3. And that is our final answer. Now, if you wanted to check that, once again, you could expand that equation and you'd get the exact same as our original expression. Okay, one more example that's slightly different again is this example here. We have 3 times x plus 2 minus z times x plus 2. This question's a little bit different because we already have it partially factorized. We've already taken out a common factor of each of our separate terms. So we can straight away see that x plus 2 in both terms, term 1 being this and term 2 being this, that x plus 2 is a common factor. Now we're left with 3 minus z. Now, if I left it like this is saying that x plus 2 is multiplied by 3 and then z is subtracted from it. But we can see in our original equation that z is also multiplied by x plus 2. So to account for that, we need to add brackets around that 3 minus z, and that is our factorized form. Okay, so now we've looked at how to do factorizing using highest common factor by hand. Let's look at how we do it on the CAS. So we're going to go menu 3, 2. All right, remember you can just press the numbers. You don't need to scroll down to select it. So if I put in one of our equations we did earlier, which one of them was x squared plus 2x, we can see that what it's done is taken x out as a common factor and left x plus 2 in the brackets, which is what we found earlier. Let's look at another one. We've got menu 3, 2, and I'm going to put in our equation 2 times x squared plus 4x. And once again, we can see that 2x has been identified as the common factor, and then x plus 2 was what was left over in the brackets. Now, it's important to note that sometimes, particularly when we look at negative values, that the CAS will display it as a little bit different, because often the CAS will take the negative 1 out as a common factor because it doesn't want to leave negatives in the bracket. So just because it does that doesn't mean that your answer is wrong. It just is another way of writing it. So if we look at our other example we did, so go menu 3, 2, we had 3 times x plus 2 minus z times x plus 2. We can see that this form is exactly the same, except what they've done is they've taken this negative sign out, and so instead of having a negative z, they have a positive z and a negative 3. So they've just swapped the negatives around because the CAS normally doesn't like to leave variables as a negative number. But our answer is still correct. You can still leave your answers as a negative. So hopefully that increased your understanding of factorizing using highest common factor. Really important you practice this method both by hand and on the CAS because you will need to know how to do both.